Hello everyone. In this video I'm going to solve worksheet of lecture 1. So let us start. In the first question we need to calculate the directing vector of each of the following lines. You know that we have two types of lines, the Cartesian and the parametric. The Cartesian, whenever you want to find the directing vector v, it's minus ba. So as you see, and minus b is b, it's already minus 1, so minus b is 1, and a, which is the coefficient of the x, is 2. The same thing in the second one, it's also v minus ba, so it's minus 3, 1. But when we have a parametric equation, the directing vector v is ab, that are the coefficients of the parameters, 2, minus 1, as you see. And in number 4 also, the directing vector is the coefficient of the parameter. In x, we don't have a parameter, so a is 0 and b is 1. In the third one, you cannot know the directing vector unless you make it in the Cartesian form. So this is the reduced form, y equal ax plus b, and I need to make it ax plus by plus c equals to 0. So we change it like this, and now I can find the directing vector b, which is minus ba, and it's minus 1 half. In the last one, also the directing vector is ab, it's the coefficient of the parameters, so it's 2, 0, because in the second one we don't have a parameter. Let us go for question number 2. In question number 2, it's we need to make the parametric equation of D defined by the following condition. In the first case, the straight line, it passes through A and it has a directing vector. So in order to find the parametric equation, I need to have a directing vector and a point. So it's already given. So we do it like this. The directing vector is the coefficient of the parameter, and the number A is minus 3, 2, we place it as follows. So here I have to switch them, okay? Minus 3 should be in x, and 2 it should be in y, okay? In number 2, D passes through the origin and it has a directing vector. So this is the parametric equation. We just put the coordinates of the directing vector before the parameter, and since it passes through the origin, then there's no coefficients, or there's no constants, excuse me, beside the parameter, because it passes through the origin. In number 3, D passes through the point O and A. So here I have to find the directing vector for this straight line, and it's very easy. It's OA, which is 2, 4, and now I can do it like this. I can put them as a coefficient of the parameter without any constant, because it passes through the center, or the point O. In the last exercise, we need also to write the parametric equation of a straight line that passes through 2 points A and B. So first of all, I should create a directing vector, which is AB, xb minus xa, yb minus ya. So AB, which is 7 minus 5, it's a directing vector for the straight line. And now I can put it like this. You can place the point A or the point B. Both of them are correct. In question number 3, I need to write a Cartesian equation of the straight line A, and it has a directing vector V. It's very easy. You should remember to draw a Cartesian equation. First of all, you should create a vector AM, where M, the coordinates of M are x and y. We don't know them. So we have vector AM, it's x minus 2, y minus 1. And I already know that AM, which is a vector that belongs to the straight line, and the vector v are collinear. So we do the dot product of them, it should be equals to 0. So as you see, the dot product is y prime minus y prime x. This is the determinant, okay? So we do the determinant to show that they are collinear, or to say that they are already collinear. So we use the determinant that says that it's xy prime minus x prime y. Okay, so this is the Cartesian form of the first one. Also on the second one, I should create a vector AM, which is x plus 1y, and vector v. AM and v are collinear, so I should apply the rule of the determinant that says that xy prime minus x prime y equals to 0, and this is the Cartesian form. Also on the third one, I already have the point A. The vector v is j, that means it's 0, 1. So this is AM, and this is v. So I do the dot product or the determinant, and this is the equation of the straight line. Also in the fourth one, the same concept. This is am and this is v. They are collinear, so I find the determinant, and this is the Cartesian form. Let us continue. Now in question number 4, I need to determine the Cartesian equation of a line that passes through 2 points, A and B. So very easy steps. The first step is to find the vector AB as a directing vector. It's 4 minus 2. Then find the vector AM, any values x and y, and we know that am and ab are collinear, so we apply the rule of the determinant that says that xy prime minus y prime x, xy prime minus xy prime equals to 0, and this is the Cartesian form. The same concept in the second one. I create a vector AB and vector AM, and they are collinear, and we apply the determinant to find the Cartesian form. The same concept in the third one. So these are direct application of how to find the Cartesian equation of a straight line that passes through 2 points A and B. In question number 5, we need to determine the director coefficient m of line AB. The director coefficient, or in another word, it's the slope. So in the first one, the slope is equal to yb minus ya over xb minus xa. So it's 5 minus 3 over 1 minus 2 equals minus 2. So this is called the director coefficient, or the slope of the straight line. The second one also, it's the same, yb minus ya over xb minus xa, and the director coefficient is 1 over 3. Now in question number 3, it's already given the Cartesian equation of D, and we need to pick out all these. In the first one, the director coefficient, or as we said, it's the slope. So in order to know the slope, you need to change the Cartesian form into reduced form that you know, which is y equal ax plus b, and then the slope is going to be minus 2 over 3. How can I find a point A that belongs to D and of abscissa 2? So I just replace instead of x2, and I find y, which is minus 1. So point A, it's 2 minus 1. And point B, it belongs also to D, but with ordinate 5. So in this case, I'm going to replace instead of the y, 5. So as you see, x is going to be minus 7, and point B, it has coordinates minus 7, 5. 2 points E and F distinct from A and B. It's very easy. Just take any value for X and any value for Y, and you find the if you put any value for X, you're going to have Y. If you put any value for Y, you're going to have X. And this is a question that have a lot of solutions, so I'm not going to answer it, but it's very easy. You just replace instead of the X or instead of the Y. And the final one is the director vector of D, and you know that the director vector is minus BA, so in this case it's minus 3, 2. And now in question number 7, and it's the most important one, we need to write the parametric equation of the following reduced Cartesians and vice versa. So if you have the parametric form, you have to make it Cartesian, and if you have the Cartesian, you have to make it parametric. It's very easy. In the first one, we have a parametric form, and we need to make it Cartesian. So the first step is to find the system again, but in terms of t. T equals something in both of them. So the first one, t is equal to x minus 2 over 3, and then the second one, t is equal to y minus 1 over 4. And you know that t is equal to t, so I'm going to take their values and put them equal to each other. And now we do a cross multiplication, and this is the Cartesian form of this parametric equation. The same concept in the second one. I'm going to find the system of t equals x minus 2 over minus 5, and t equals minus 5 over minus 5, y minus 5 over minus 5, and then t is equal to t. Then I take their values, cross multiplication, and this is the Cartesian form. Now, what if I already have the Cartesian form and I need to make it parametric? As I explained before, you have to take a parameter. You should create a parameter by your own. There are a lot of correct answers. For example, you can take x equal to t, you can take x equal to 2t, you can take the y equals to t. So it's up to you to start with any value you want, and then the second one, it will follow up the first example. So for me, I chose x equals to t, and I replace it, and I got y equals t plus 1 over 2. This is very easy. In number 4, 2y plus 5. I've told you if one of the variables are missing, you have to take it equals to the parameter. So since x is missing, then I'm going to take x equals to t, and in this case, y is equal to minus 5 over 2. In number 5, y is missing, so I need to take y equals to t, then x equals to 4. Excuse me. In the last exercise, it's y equal to x plus 1. It's very easy. You just replace x by t, and y equals to t plus 1.